Hello and welcome. My name is Vishwanath M. In this video, let us try to learn and understand the concept of circular queue and the related program. If you're following the VTU syllabus, this is program number 6 of Data Structures Laboratory. Before we dive into the video or the program, just want to express my thanks for all the good feedback received on the other videos, and following a request for the videos of all the programs. This is an effort to create one for program number 6, or that is circular queues. So let us dive into the video now. A very solid understanding of the concept or the theory is required to write efficient or effective programs, and the same goes with queues as well. So let us try to understand or get at least a brief understanding of what normal queue is first, and then understand how circular queue is different, and then jump into the program. Queue, first of all, is a first in first out data structure. It's normally called FIFO data structure. It is easily relatable to us because all the queues that we see anywhere across all the places is the same. So the first person to enter the queue will be the first person to exit the queue. So that's the normal tendency, and that's the normal occurrence everywhere around us. The same goes with a normal queue, and these are two common operations that you would encounter regardless of the language. See, in this case, and regardless of the language, these are the terms given to the basic queue operations. Enqueue means adding an element to the queue, and dequeue means removing an element from the queue. So end of the day, a good understanding of queue, stack, or so many other data structures is based on how good you have understood the concept of arrays. So just to mention, at the end of the day, it's an array, be it a character array or an integer array or any array for that matter. It's an array that we are using at the background, and we are only manipulating how the input and output operations happen. And based on how we manipulate or how we configure the input output operations, different data structures are named. That's the core understanding of all data structures. Okay, let us consider some scenarios here with normal queue, and then jump on to circular queue. So as we already know, this is an array at the core, but let us now call it a queue. And in a queue, we have two pointers or two indication variables, front and rear. So as they mean, as a sound, so they mean. So a front is where the exiting or queue or removal of elements happen, and rear is where insertion of elements happen. At the beginning, let's assume that they both are at the first position or the 0th position. So you would see the value remain here, that is how many elements can we still enter or can we insert into the queue is what remain indicates here. So considering a case where two elements are inserted, f stays at 0 because that's where the exiting has to happen, and since nothing has been removed yet, f stays at 0, and r, which was at 0, is now at 1, and these are the two elements. And if four elements are added or inserted, another two elements would come here, and hence r is now at 3, 0, 1, 2 and 3, r is at 3 and f is at 0. Now remain clearly shows that there is one spot or one vacant position for an element to take place. Now let's consider a removal operation. Let's assume, or let's see that the first element is removed. So the first element being a. So again, going back to the basic, the first element that has entered the queue was a, and now it is the first element to be removed, because circling back, normal queue is first in first out data structure. So once the first element is removed, the variable f or the location indicator f is incremented, and now f is at 1 and r is at 3. So this is where it gets interesting, or this is where the concept of circular queue makes or gives you some value. So as you can see, in the array which has 5 positions, or the array which has a capacity of 5, you see that the firstmost element or the leftmost position is empty. or we could say that the leftmost element was removed and so it is empty, and the last or the rightmost element, rightmost position has never been occupied yet and so it is empty. So just like how we would see or how we would guess, we should think or we should assume that two elements could be inserted, but that's the limitation of normal queue. Since we are upgrading, or since we are updating, I should say, the values of f and r as we remove and insert elements, we see that f is now at 1 and this becomes the first element to the queue, and this position almost becomes unusable. So this is unusable or it goes in vain. So currently even though the capacity of the array is 5, the capacity of the queue is only 4 and only one element could be inserted, and that's what I've written here. But actually two slots in the queue are empty, but even though queue allows us to enter, or a normal queue I should say, normal queue allows us to enter only one element, and this is the inefficiency. Alright, so with this inefficiency, to solve or as an answer to this inefficiency, circular queues came into existence or came into picture. This is a very I request your attention on this part of the screen. You would see that tube-like structure or circular structure is normal. This is the familiar representation of circular queue, but technically and logically this cannot be possible because at the end of the day arrays are sequential collection of elements and you cannot expect them to be in literal sense in a circular fashion. So at least in this video and for my explanation, I would not be using this sort of a representation, but still to imply or still to depict that it is circular fashion, you would see arrows like this, dotted arrows like this, so you could still imagine or appreciate that this looks like a circular queue. Even before we enter or even before we understand the program, you might guess that once the last element is now last position is now occupied, if the firstmost or if the leftmost element or the leftmost position is empty, the circular queue should function in such a way that the next element inserted should go and take the leftmost position. So this is the whole concept of circular queue. So what you see here will be implemented in the program. So either ways we could understand the program and come back here and see how circular queues make it efficient. So let us now understand the program itself. Like any other C program, there are a set of header files, stdio and stdlib.h. Even in my other videos I would have explained why we use them, and hence let us not spend too much time around the basics. We are defining a constant CQ size. CQ means circular queue. Circular queue size of 5. To keep in sync with the diagrams here, let us keep the same constant. This is again left to your choice. You can make it 4 or 3, but 5 is a good number to choose. We are declaring a set of global variables here. I say global variables because these variables are out of scope of each they are not limited to the scope of any function in the program. So the variables that you would have defined inside a function would be limited to that function itself, but the variables that you define outside all the functions are called global variables, and they would be accessible to all the functions. So that's the advantage of global variables. So this is not the best practice. This is not the industry recommended way of writing programs, because having global variables has its own cons, but at least for laboratory purposes, having global variables would make the function prototype simpler and easy to remember and easy to understand as well. So let us understand the variables. Int count, count as you would understand or as you would guess, indicates the number of elements in the queue, and we are creating a character queue here because the requirement of the lab question says that it's a circular queue of characters. So we are creating a character queue of CQ size, which is 5, and as I've already explained here, we have to use two location indicators, F and R, and we are initializing them accordingly. So normally any data structure would have to have would have to be understood from insertion perspective, deletion perspective, and displaying how the displaying what the contents of the data structure is, and of course we would expect a main function where we see a menu like code, as in most universities and most exams, the main function would be somewhat very similar to this, because it is normally asked to write a menu driven program. So let us start our learning from the main program and then jump to the respective functions. So void main or main function is where the execution of C program would start, and inside the main function we are creating or declaring two variables, char item and int choice. So item, as you could guess, char it's a character type variable, and we use this for insertion operation. And int choice, since there is a menu, you can always guess that there should be a choice, and it's of type integer. So this is the statement we display in order to make the user understand what the menu options are. And what you see here, for followed by two semicolons, is a way to create infinite loop. So this is one way. This is not the only way. You can also create a for loop. You can also create an infinite loop using while structure as well, but this is one preferred method of creating infinite loop. And as we enter the for loop, every time we enter the for loop, this statement of enter your choice would be displayed on the output screen, and scanf function would accept the input, and based on the input we have a switch construct. So switch construct basically considers each case, and if choice matches with that particular case, the code adjacent or the code that belongs to the case would be executed. So if the case is 1, which is insert, we will ask the user to enter an item to insert, accept the input, and we will call the function insert with passing the parameter item, and we will break the case. We will understand insert function later on, but let us finish the main function first. Case 2 being delete, we simply call delete function because there is not really any parameter that we have to pass when deleting an element. Case 3 is when we will display the queue. Again, you could this is a choice left to the user. This is not a mandatory requirement. You could still remove the parameter list within the function prototype. Again, the understanding or the explanation for this is we have defined or declared all the global scope parameters as global variables, so we need not pass those variables again using the function. They wouldn't create any errors if you do so, but it would just be redundant. And case 4 is when we will exit the function or exit the program, because a for loop should have an exit statement, otherwise it would just keep running unless you force shut the execution. So this is a very simple main function, basically has a menu and switch construct to execute each choice in the menu. So let us now understand the first case, that is insert function, and we'll follow with the others. Okay, void insert function is a very simple function, as you could see here. It would accept the input called item coming from the main function. A very important check or a very important validation to make in almost all data structures is if the data structure is already completely occupied, we will call it by different names. For example, in stack you would just say stack overflow or stack full, and since we are dealing with circular queue now, I have just used the abbreviation. So if the count is equals to CQ size, so CQ size is the size of the array or size of the circular queue in this case, and count indicates the number of elements in the circular queue. Initially we would have initialized to 0. As we enter the elements, you would see that count is incremented. So in a case where it is completely occupied, something like this, so the statement or the message we have to give is circular queue overflow condition has occurred, or circular queue is full. So that's the print statement here, and once if this condition is true, we could just return from this construct, not bother about the others. So that's the if part. But if it's not full, or if a circular queue overflow condition hasn't occurred, this is how we insert elements to a circular queue. Now here is where seeing this image or seeing this explanation and comparatively understanding the code would make it really easy. Normally, when we are inserting an element to the queue, all we are supposed to do, or all we were used to doing was incrementing the rare variable, that is r variable, and just inserting an element there. So as you could see here, r was at 0, next r would be incremented to 1, and it would be 2, and it would be 3, and until it reaches the end of q. That is how we used to do in normal q. But since we what was the limitation? So the limitation we already saw here. When r is at 4, even though there is an empty element, empty position, or a vacant slot here, r cannot readjust to 0, because from an array perspective this is 0, and r should be pointing to 0 if we had to insert an other element, but with normal q that was not possible. Hence you would see a slight modification in how we manipulate the value of r. So let us see the image and understand here. So consider the case where the first element was removed. So you could understand that initially it was completely empty, and we inserted all the elements. That's why r is now at 4, and then we removed the first element. So considering this case to be very precise and very simple, so we are addressing how the circular queue addresses the limitation of normal queue. So r, which is equals to 4 at the moment, should be made to point, or should be made to have a value of 0. How do we do that? Is by this. So the initial part of the code, that is r adding 1 to the r, or incrementing r, remains the same, but we add another part to the code, that is modulus phi, or modulus size. So that is what you would see here. R is equals to r plus 1 mod CQ size. So mod operator is an operator which will return the remainder of operation. So r plus 1 is, so let us understand here, r plus 1 is 5, and modulus, as I said, it will return the remainder after division. So 5 mod 5, 5 divided by 5 is 1, and the remainder would be 0, and hence the value of r now would be 0. That is what we wanted. So you could understand that even for the other cases. So let's just assume, or let's consider the case, let's say here r is now at 1, and assume this is also a circular queue, because at the end of the day they are all just the same array, and it's just the way we are manipulating the value of f and r. So assume that this is a circular queue, and let us see if the same formula works for normal insertion of elements. So this was a special case where r had to be reset to 0, but a normal case would be something like this. We are inserting elements and there are still vacant spots here. So what you would assume, or what you would guess is, next the value of r should now be 2 for the new element to come into the queue. So let us see if the same formula works. So r is now at 1, 1 plus 1 is 2, 2 mod CQ size, 2 mod CQ size is 5 here, 2 mod 5 is again it is just the same thing, because 5 0 times is 0, and the remainder of the operation is 2. So which anyway makes the value of r to be 2. So what I just tried to explain or imply here is that this this operation that you see here, r is equals to r plus 1 mod CQ size, works perfectly fine for the normal way, and it works as expected when r is at the end of the array, or end of the queue, and it will work as expected to reconfigure or reset the value of r to 0, and then again make sure that we keep the loop running. So that's the whole point of circular queue. So once we are here, if there is a vacant spot here, the r has to come here, and the new element would take this place, and it would just continue the cycle. That is why you would normally see this sort of a representation, but I always prefer to keep the same representation convention, but only explain how the f and r values are manipulated. I have another image here which talks about the mod logic. So just this is just what I explained. So when r is at 4, we want r to become 0. That is why we have come up with this sort of a formula here, r plus 1 mod CQ size. So as I just explained, r plus 1 is what is done in normal queue, and with circular queue this is what you have to type or code additionally, r plus 1 mod CQ size, and we just saw how 4 plus 1 mod 5 is 0, and that is what we need for the next element to come and take the place of 0. So this was the mod logic. We will come back to this later when we see that code. So we would go back to the other image now. So once we have calculated the value of r, this is a very basic operation. CQ of r, item takes the position of CQ of r, and we increment the value of count, because every time a new element has been inserted to the queue, circular queues more specifically, we will increment the value of count, and we just print the statement that item inserted is %c and item, which is what we did in the insert function. Moving on, we will understand the delete function now. Void delete, as the function indicates, is aimed to delete an element from the circular queue. So like how we had an initial condition for insert where the queue was full, here we have a condition which checks if the queue is empty, because if the queue is empty, there is essentially nothing to remove. So how do we check that? If count is equal to 0, we just print circular queue underflow and return. But if this is not the case, suppose we have some elements in the queue, this wouldn't work, and what happens in that case is what we understand right now. So while we are doing deletion, the first step is always, so always try to circle back to the basic concept of FIFO, that is first in first out, and always remember that DQ operation always happens at the F variable or F location. So always remember that, and insert always happens at R location or R rare indicator. So because any queue for that matter, you would always and normally go and join the queue at the end or at the rear, and the person standing at the first or the frontmost person would leave the queue. So that is the normal convention, that applies the same with programming logic as well. So always remember that delete function deals with or handles with F variable, which is the front variable. So we just create a dummy temporary variable char item del item deleted is equals to CQ of F, which will just store it here, and it will decrement the value of count, which is expected, because after we delete an element the count should decrease, and we print the element. Print item deleted is what we just stored, or what we just copied from CQ of F. After the deletion is done and after we displayed it, this is one additional condition or additional I would say constraint with circular queue. So in the case when F is equals to R, that comes into picture here. That is why I've explained that in a separate image here. F is equals to R logic. So when there is only one element, that too it is the last element. So how we would see that? Initially it was an empty queue. It was an empty queue like this. We inserted elements like A, B, C, D, E, and we just deleted elements individually. A was deleted, B was deleted, C was deleted, D was deleted, and now we are only left with E. And how we did the deletion operation? F was at 0 initially and F was incremented, and now F and R both points to the same position. So when we have this scenario, or when we have this situation, what is the next step? So if we delete, or if we delete this last element, which is E, it is obvious and it is easy for anyone to guess that we will have to reset both F and R values to make sure that the queue is now empty and queue goes back to its initial state. So after deleting E, after deleting the last element, we have to reset the queue. And how do we do that? We just assign, or we just initiate the values of F and R as they should be when in the initial configuration. So if F is equals to R, we just initiate, or we just assign the values 0 and 1, 0 and -1 to F and R respectively. So after we this is just a condition to check if this condition is not occurring, well and good. So after we delete an element from the queue, so what I'm trying to explain right now is, so if I delete the element B now, F is now at 1, and F should then be incremented to the next position, and that will happen in this part of the code. Again, this the logic or explanation for why we have an additional part in the formula is just the same. It works just the same, or it works exactly how it would for only this F is equals to F plus 1, that is the normal operation. But for circular queue, because it's circular in fashion, and we have to reconfigure F and R, this additional part in the formula or additional part in the code comes into play. I have already explained why the modulus CQ size is important here, and the same applies with f as well. So we have understood insert operation and delete operation, which covers the core of or heart of the program. Now we are left with display function. A display function is used to display the status of the circular queue, or you could also just say that display is used to display the contents of the circular queue. And how do we do it? Again, this is a basic condition we check. If count is equals to 0, we just print circular queue is empty and when we return, and if not, this is an additional step. So this is what makes it more valuable. We are actually presenting, or we are actually indicating the values of f and r when we are displaying the circular queue contents. This is important because in circular queue we know that r and f gets reset, and the value of r and f depends on this formula. So it is useful to know the value of f and r for better understanding. So this is just a basic print statement. F and r is printed using the printf line here. So how do we print the contents of the circular queue? We are creating a dummy or a temporary variable called t, and t is initialized to f. Now a very interesting question, if you have got, here is the answer: why f and not r? So we always read, the normal tendency is reading left to right, or seeing the queue from front to the last, or front to the rear. So that is why we want to start at f, and you would see that t is what we use to print the contents of the circular queue. So this is a good understanding to have. We start from the front, that's why t is initialized with f, and we print the statement CQ contents, and we use a for loop. Int I is equals to 1, I smaller than equal to count. So we are just, a very important understanding here is, so when we have a circular queue, we just want to print all the contents or elements of the circular queue, and it is not how we print in a normal queue, because in a normal queue front will always be behind r, but in this case it is quite different. So you would have seen, or you are seeing right now, that after r is now reset to 0, r is now taking the value of 0, or r is now taking the position of 0. So circular queue works slightly different. So we are considering the count variable and making sure that all the variables in the all the elements in the circular queue are printed from front to rear. So for int I is equals to 1, I smaller than equals to count, I plus plus, printf %c, because it's a character array, CQ of t, t is what we just created, and every time we have to increment t. So this is one, I could say, rule of thumb you could remember for all circular queue operations. Instead of just incrementing like t is equals to t plus 1, add an additional part, that is t is equals to t plus 1 modulus CQ size. We have already understood multiple times that how this modulus CQ size works, and hence it would require no repetition. So this is how we print the elements of circular queue, and this is just a line to this is just a printf statement to enter a blank line, so that the whole program, when it comes on the output screen, looks better. So we have understood the whole program, the initial header files, the global variables, all the functions, and the main function itself. So now let us understand how the execution works. Like any other C program, how we execute a C program is using GCC compiler or CC compiler. GCC P6 is the name of the program, .6, and if when you are running on a Linux environment, this being a terminal, if you see that the cursor is just blinking and you are not seeing any error message or warning message, that means there are no errors or warnings in the program, and it is ready for execution. And how do you execute? It is with this code ./a.out. You are already familiar with this because I am using the same environment and the same format for all the data structures videos. So ./a.out would enter the execution. So as expected, it is currently entering, or it is just printing the print statement. Now just to make our execution, or just to make our understanding better, so let us try to keep the let us try to keep the program here as a the image here as a reference, and do the execution parallelly. So let us enter the choice. Enter. Let's see if the first. Let's see if the queue is empty first. So we enter 3 and it says circular queue is empty. Now let us insert elements. So as you would see that let us come to this state. Let us do insert operations 5 times. So insert element, insert and enter item to insert. It would be A, and next choice would again be 1 to insert, and it is B, 1C, 1D, 1E. So we have executed insert operations 5 times. So let us now see how the circular queue looks by calling the display function. So there we go. So this is where I said it. We are using, or we are presenting the status of the circular queue. F is at 0 and R is at 4. So this is the if until this point, normal queue and circular queue would be no different. So the difference comes only when R goes back and takes the position of 0. So F is equals to 0, R is equals to 4, and the circular queue contents are as follows. Now let us jump to this side. So what we want to do first is to delete an element. So let us delete the firstmost element by entering choice of 2. There we go. Item deleted is A. Let us now display the contents of the program or the stack. So here it is. So B, C, D is the content of the circular queue, and F is now at 1 and R is now at 4. So again, so why I position the image is that so it kind of reinforces our understanding. So what we are supposed to do next? We are supposed to add an element F. So how do we add an element? The choice is 1 and element to insert is F. Okay, here is where we need to spend a little time understanding this representation. So as you can see here, B, C, D, E is already present in the stack. I mean is already present in the circular queue. Excuse me for that. Now we have inserted a new element F. So F is taking the position of R is equals to 0, and for our understanding, I have because it's a circular queue, I have placed F before B. But what you would expect, so when we display the contents of the circular queue, as if you have followed my explanation so far, when I was explaining the display function, I said we always read the contents of the stack from contents of the circular queue from front to rear. So in this case, front is here and rear is at rear is at 0. But as I just said, so we always start from the front and make sure that all the contents of the circular queue are printed. So what I'm trying to give you a clue is you wouldn't see F, B, C, D, E here, even though it is how it will be internally. How we are printing it or how we are representing is B, C, D, and the last the newly inserted element, which is F. So let us see if that is how it is functioning. So enter your choice. There we go. So B, C, D, E, and F. So just because F is here, it doesn't mean that R is now 4. So this is where circular queue is interesting as well as needs some attention. So F is the newly inserted element, as we just did. Enter item to insert. It was F, and the latest element inserted was F, and but where it has inserted at R is equals to 0. But when we are printing the circular queue contents, we always start from the front and go on till we cover all the contents in the circular queue. So that is why you see B, C, D, E, F. So let us continue the execution, keeping this as a reference. So after this, let us now remove an element. So again, so if you can appreciate here, the value of F or front is now pointing at 1. So if I just do a delete operation now, B would be deleted, as you can see here, and let us see the contents of the stack again. So the contents of the stack goes like this. So again, here you would require some focus and understanding. So we always start from the front. F is equals to 2, C, D, E, and then we come to F. That is what we have done here. C, D, E, F. The value of F and R is also in sync with our explanation image. So next we add another element, that is G, how do we add an element, which it is by entering a choice of 1, and let us add an element called G. So let us see the contents of the stack again. So we have almost completed the whole execution. We have tried everything in terms of adding and deleting the contents or elements to our circular queue. Let us now just see if it also does check for overflow and underflow conditions. So if I try to insert an element again, let's say L, it would just say circular queue overflow, because the size of the circular queue is 5 and 5 elements are already there, and if I try to insert another element, it will just give me a message of overflow. Let me do deletion 5 times real quick, and so that we can see that now we have already removed all the 5 elements C, D, E, F, G, C, D, E, F, G. So if I try to do a delete operation again, I would see a message circular queue underflow. There it is. So we have understood, or we have clearly demonstrated all the operations: insert, delete, display, overflow and underflow, also displaying the status. So let us now gracefully exit the program by entering a choice of 4. There we go, we have come out of the execution. So in this video we have made our best efforts understanding the concept of circular queue in reference or in contrast to normal queue, and understood the whole logic of the program, and also completed with the execution. Hope this helps. Thank you.